Hello students, today our topic of discussion is circulatory motion. Now we know that motion, what is a motion? When any object changes its position with respect to time, the object is in motion. Now there are two kinds of motion. One is linear motion, when an object moves in a straight path, and another is curvilinear motion, when an object moves in a curve. Now this curvilinear motion is composed of this circulatory motion. That means circulatory motion is a part of the curvilinear motion. When an object rotates along the circumference of a circle, its motion is called circulatory motion. When an object rotates along the path or along the circumference of a circle, the motion of the object is called circulatory motion. Now, as we have some terms like displacement, like velocity, and like acceleration in linear motion, here also in circulatory motion, the displacement of the object with respect to time is called angular displacement, because it is measured with some angles theta in radian unit. The velocity of the object is called angular velocity omega, unit will be radian per second, and the acceleration of the object which is in motion of a circulatory motion is called angular acceleration, denoted by alpha, given by velocity by time omega by t. So the unit of angular displacement is radian, unit of angular velocity is rad per second, and the unit of angular acceleration is rad per second square. Now this acceleration, when an object rotates in certain circular path, the acceleration along its radius towards the center of the circle is called centripetal acceleration, given by omega square into r. That is, centripetal acceleration AC is equal to omega square. Omega is the angular velocity of the object, square of omega into radius of the circle r. Now omega is also v by r, so v square by r square into r. So acceleration, centripetal acceleration of the object will be v square by r. So due to this acceleration, we know that when an object having some acceleration, a force definitely acts on the object given by mass into acceleration. So the force which acts due to centripetal acceleration is called centripetal force, given by mass into centripetal acceleration. That is, centripetal force Fc will be mv square by r, or Fc is equal to m omega square r. So this force, this centripetal force, acts towards the center of the curve or towards the center of the circle, and to balance this force, to balance this centripetal force, another force acts outward direction. That force is called centrifugal force, Cg, centrifugal force. So, and both the force, centripetal force and centrifugal force, the velocity or the amount or quantity or the formula remains the same, that is mv square by r. Next we move to another topic, very important topic, banking of roads. Now imagine the situation that you are cycling and certain turn comes in the road. So you have to take that sharp turn, you have to bend either outwards or inwards. So that bending is called banking. That bending is called banking. When there is some sharp turn of the roads are not horizontal, it will tilted to some angle. That angle of tilt is called banking angle. This theta is called banking angle. Banking angle. Okay. So what is the advantage of that banking angle? The most important advantage of that banking angle is to provide the amount of friction between the roads and the tires of the vehicle, so that the vehicle does not slips or skids. To take the turn, that force, centripetal force, will be given by mv square by r, and the frictional force offered by the road and the wheels or tires of the vehicle is frictional force will be mu into m into g, where mu is the coefficient of friction. So in the for the safety of the movement or for the safety of the turning, it is very much required that frictional force must overcome that centrifugal force. So f of mu mg is greater than equal to mv square by r. From there you can calculate mu. So mu is equal to tan theta, so v square by rg. So tan theta will be given as v square by rg. Now here theta is known, r is known, g is known, so v will be known. So to take the sharp turn inside a road, along a road, the safety board is always mentioned. If you notice that while taking a sharp turn along a road, a safety board is mentioned where it is written that maximum speed is that 60 km per hour or 50 km per hour. By doing this type of calculations, the engineers made this board to that, so that the car can overcome or can take sharp turns without skidding or without slipping. Next, our topic of discussion will be that motion in vertical plane. Imagine the situation that an object or a stone rotates in this manner, vertically manner. Okay, so we have taken three positions of that stone. One is position A, which is the lowest position or least position of the stone. Position C, which is the highest position of the stone, and position B. In the meantime, between A to C, there is another position B. So at B, the weight that lies mg can be broken into two components, mg cos theta and mg sin theta. That mg cos theta provides the necessary force to balance the tension of the string. So net force acting at B will be tension of the string minus mg cos theta given by that centripetal force mvv square by r. So what will be TB? mvv square by r plus mg cos theta. And at point C, both the tension of the string and the weight of the object acts downward. So C. So at point C, so T and mg both downwards. Tc plus mg, that will be balanced by mvc square by r. Now at point C, while moving from point A to C, we covered at an angle of 180 degrees. So angular displacement is 180 degrees. So at TC, cos 180 will be minus 1. So tension at TC is equal to mvc square by r minus mg. Now at point C, that TC will become 0. That means mvc square by r will be equal to mg, or vc square equals to rg, or given by vc is equal to root over rg. So the velocity at the highest point will be root over rg. Now we know as we move from lowest point to highest point, there is a gain in potential energy and in loss of kinetic energy. So while moving from lowest point to highest point from A to C, the loss of kinetic energy is T, loss of kinetic energy half mvb square minus half mva square is equal to gain in potential energy mg r plus r cos theta. So this is your mgr and this much is your r cos theta. So mg r into r plus r cos theta. So at vc we know vc, what is vc? rg, root over rg. So this will become half m rg minus half mva square will become mg into r plus r cos theta. So all m's become cancelled. So it will become half va square is equal to half va square is equal to half rg minus rg minus r cos theta. So va square will be rg minus 2rg minus 2r cos theta. So va theta is 0 at a theta is 0. So va square equals to cos 0 is 1. Cos 0 is rg cos theta. Rg cos theta is 1. So it will become 5 rg. So va become root over 5 rg. Okay, so this is become va is equal to root over 5 rg. So a at point A, the speed of the object will become root over 5 rg. Okay, and what will be the velocity at tension at A? So do that in that case T minus mg va square by r. So T at A will become mg plus m by r into 5gr. R is 6 mg. Tension at A is equal to 6 mg. And what will be the tension at C? Tension at C is 0. Tension at C is 0. And tension at D, suppose at D point, which is horizontal. So angle is 90. So angle is 90. So D will be m vt square by r plus mg cos 90. Cos 90 is 0, this one cancel. So Td will become m vt square by r. This is your tension at D. So here by means of this calculation we can calculate that the minimum velocity at the lowest point, maximum velocity at the highest point, the tension at the lowest point and the tension at the highest point. This is all your motion in vertical plane.